Hello and welcome to the first in a series of videos dealing with network security. In this first video we'll be looking at voice over IP security. Specifically we'll be looking at how you can rebuild the audio stream from the RTP package, that's the real-time transport protocol package that carry the audio, by the use of the Wireshark protocol analyzer. This video was derived from a presentation that I gave in July of 2014 at a series of 3 CompTIA conferences talking about how you can teach the Security Plus, the CompTIA Security Plus. Now in this particular video the configuration setup is a fairly basic configuration setup. It doesn't contain some of the more advanced security techniques that you really should have if you're setting one of these voice over IP systems up. For instance, port security, IP-DHCP snooping, separate voice VLANs, preferably using secure real-time transport protocol. If you wish to replicate this video or possibly demonstrate it to your students, there are 2 main approaches. You can go via the Cisco pathway, so if you're a Cisco Networking Academy for instance, you have a 2800 series routers or 2900 series routers or even GNS3, you can use those to create a voice over IP server and then use the Cisco IP communicator as a soft phone or real Cisco IP phones if you have them. The other approach, if you're not a Cisco Academy, you can use open source software. Set up a Linux box, install the Asterisk soft PBX. Either approach works very well. In this particular instance what I'm going to do is I'm going to use the first approach, and we'll use a Cisco router, in this case a virtual router running in GNS3, running on a Linux PC. The Linux PC will have 2 network interface cards, and you'll see exactly why we'll have 2 network interface cards on the Linux PC later. They will be plugged into a Power over Ethernet switch, and there'll be a real Cisco 7970G IP phone also plugged into the switch. And now for the fun part. Now we're going to do the configuration. I'm going to do the configuration mostly using Linux. Linux is a free operating system and it comes with tens of thousands of pieces of software which are also free and very useful for teaching computer networking, network security and systems administration. I'm going to type Alt F2, which brings up the Run dialog box, and any command you type in there that's on the system should run. We're going to type in gnome-terminal, which opens up the GNOME terminal, which is a bit like the command prompt in Windows but a lot more powerful. I double click on the title bar at the top there to maximize the window, and I'm going to become the root user, which is like the administrator in Windows. SU-, and tap in my root user password. That should be a particularly complex password because anybody who becomes the root user on the system has considerable power and can do a lot of damage. I would like to know what the configuration of my network cards are, so I'm going to type ifconfig, very similar to the Windows command ipconfig. And you can see that my network cards have no IP version 4 address. They do have IP version 6 addresses, but no IP version 4 addresses. So the first thing I want to do, I'm going to clear the screen. Clear. Who said Linux commands were difficult? And we will set up an IP address on Ethernet 0. How do we do that? ifconfig Ethernet 0 and tap in the IP address 200.1.1.253, and I would like to put a 24-bit subnet mask, or 255.255.255.0. I don't need to type it in longhand, I can just say /24, and that will put a 24-bit subnet mask on. If I hit the up arrow I can put in previous commands, so I'll go back to ifconfig and just make sure that that IP address is taken. 200.1.1.253, and there's my 24-bit mask. 8 binary bits, 8 binary bits and 8 binary bits, 24 bits in total. That's good. How do we clear the screen? Just type clear. Rather than typing it, I'll use my up arrow to find it again. Screen cleared. Okay, next job, start up the router emulator. GNS3. I'll run it from the shell window, and I'm going to put an ampersand at the end. So GNS3 space ampersand. The ampersand means it will run in the background, and it will allow me to continue using that shell window. I will give this a name. I'll call it test 1, 2, 3, 4, 5. and I'll save the non-volatile RAMs. That's the router NV RAMs, are like the startup configuration on the router. It'll allow me to save the configurations on the router. Okay, now devices on the left, pick a router. I'm going to pick a 3600 series router and put it on the desktop. I'm also going to pick what's known as a cloud, and I'll put that on the desktop too. And then I'll close the device configuration box that pops out. Okay, now the cloud is a particularly useful device. It'll allow me to bridge the virtual interface on the router to the real interface on my PC. The way you do that is you right click on the cloud, go to Configure, C1 for Cloud 1. This is a Linux computer, so Linux Ethernet network input output, root access required, that's why I had to become root. I'll choose the network card on the PC that I wish to bridge to, which will be Ethernet 1. No, it won't, it'll be Ethernet 0. That's it. That's the network card that I just set the IP address of 200.1.1.253 on. And we'll add that. So I've got network input output bridging to Ethernet 0 on the PC. Apply, OK. Now we will wire up the network by going to the connector tab, choosing manual, picking fast Ethernet 00 on my virtual router and connecting it to Ethernet 0, which is the real network card on my PC. Okay, and then we'll start the router up. If I drop down into the console down here, I can type list to list running devices, and I can see that I have a router called R1, which is the 3660 router running, and its console, which is the management interface, is accessible on the port number 2101. Now I could hit the console tab here, but that would open up in a window that's separate. What I wish to do is try to run everything from the same window. Just use tabs, it's a lot easier. Clear. If you don't want to use clear, you can hit Control L and it'll do the same thing. Now if I hit Control Shift T, I can open up another tab. So I've now got two tabs, one with me as the root user, one with me as a normal user. And I'll type telnet localhost, the local machine, 2101, the port number that connects to the router, and we're on the router. I'm going to go through this fairly quickly because this is designed for people who've done a little bit of Cisco. Enable, which I can shorten to ENA or even EN. CompTIA, configure terminal. Oh, before I do that, exit. I need to set the clock, because if I type in show clock, you'll notice that the clock's got the wrong time and the wrong date on it. This is rather important for the phones because the phones will get their information off of the router. So how do we set the clock? Clock set, and the time is 19:57:00 on the 24th of August 2014. Bang. Get a little console message pop up saying that somebody set the time on the router. That was me, so I'm okay with that. And now we'll go back using the up arrow. Notice how the up arrow puts the previous commands in, just like on a Linux machine. And we'll find CompTIA, or configure terminal. Now I will set up the IP address on the interface fast Ethernet 00. I can type INT, hit tab, FA, hit tab. The tab speeds up typing considerably because it always completes the command providing there's enough unique letters in the amount of the command that you've typed. Okay, interface fast Ethernet 00. How do I set the IP address? IP address. Okay, 200.1.1.254. Now unfortunately I will have to type this in the longhand way because it doesn't accept a /24. Okay, I have the IP address set on the interface fast Ethernet 00. All I need to do is switch the interface on with no shutdown. Okay, type exit to come out of interface configuration mode, and we'll go into telephony service setup. Probably wouldn't have covered this if you were doing the CCNA, but it's very straightforward to turn one of these routers into a telephone control system. Telephony service setup. Do I want to set up DHCP? Yes, I do. Tap in the network. The network we're using is 200.1.1.0. The subnet mask was 24 bits, or 255.255.255.0. TFTP server. The phones use a TFTP server to get their firmware images and things like that across to, and their configuration files. So the TFTP server is the router. It's the interface that we've just set up the IP address of 200.1.1.254 on. So we'll tap that in, 200.1.1.254. The default router, it's the default gateway. Again, the same, just hit the up arrow. Do we want to start telephony service? Yes, we do. Enter the source address. Guess what? That's the router. So 200.1.1.254. The skinny port is 2000. Anything in square brackets is a default. Skinny is the call signaling protocol. Many systems use SIP, Session Initiation Protocol. Cisco phones use Skinny, the Skinny Client Control Protocol, and that runs on port 2000. How many phones do we want? We'll have 2 phones. Do we want to assign dual lines? No. What language do we want our phones to be? English. Call progress tone, that's the dial tone. Different countries have different dial tones. We'll say UK, number 9. First extension, 2000. So my phones will be 2000 and 2001. And we won't put anything flash on like direct inward dial or voicemail, so I'll just say no to those. Do I wish to change any of the above? No, it looks fine. And it should complete 2 phones. Yes, and we see that interface ePhone DN, that's directory number or line 1, ePhone DN2. So I've got my 2 phones now. And we're ready to go. So what's the next step? The next step is to plug in a real phone. So if I pull across the webcam picture, and this is a real phone, and we will plug in the Cisco 2970G IP phone, and you'll notice the light's starting to flash at the bottom. I've just plugged the phone into a power over Ethernet switch, so that's supplying power to the phone, and it's also connecting the phone to the Linux PC, which is by bridging, connecting it to the virtual router. So the phone will now hopefully start to load up and register with the virtual router. In the meantime, if I go from the tab that's the virtual router and I move across to the Linux box, let's set up the other Ethernet interface, because currently I only have an IP address on Ethernet 0, which is bridged to the virtual router and goes through the switch to the phone. I'm now going to set up an IP address on Ethernet 1, which is also connected to the switch, and we'll get that IP address using DHCP. So DH client, this is how you use Linux to get a DHCP IP address. DH client Ethernet 1. And what that should do is it should obtain an IP address. If we go into the router and do show IP DHCP bindings, we can see that an IP address has been given out by the DHCP pool on the router, an IP address of 200.1.1.2. Hopefully that is the IP address on Ethernet 1. It is. Had me worried for a second there, seemed to take a long time, but Ethernet 1 has an IP address of 200.1.1.2, which has been given to it by the DHCP pool on the virtual router. In fact, this phone is just in the process of registering at the moment. And if we move that out of the way slightly, we'll notice that the phone is registering with an IP address of 200.1.1.1. Okay, let's see if that IP address has also come from the router, which of course it has. That's why we created the DHCP pool on the router. Okay, looking good. While that phone's registering, we'll start up the second phone, which is running in a virtual machine. This virtual machine is bridged to Ethernet 1. We've just given that an IP address using DHCP. If I look at the interface on this phone, we should see, look at that. The computer has an IP address of 200.1.1.3. This virtual machine, which is bridged to Ethernet 1, has gone through the switch, back out of the switch into Ethernet 0 and connected to the virtual router and pulled an IP address. Isn't that crazy? Okay, we'll now start up the Cisco IP communicator, which is known as a soft phone, or software IP phone. And there we go. So just to recap, that's a real phone and that's connecting to a virtual router. This is a software phone running on VirtualBox, more free software. It's amazing what you can do with free software. And that is also going to get its IP address, well, it's going to actually use the IP address of the Windows XP box, but the Windows XP box got its IP address from the virtual router. There we go. This one is now registered with a phone number of 2000. This one is registered with a phone number of 2001. Let's try calling from one to the other. Yep, that works. Put it down. Okay, we've even registered that we got a missed call. How good is that? Right, now for the security. We're going to fire up Wireshark. And what is Wireshark? Wireshark is a protocol analyzer. It allows us to look deep inside the packets. I'm going to tell Wireshark to look at the local area connection on the Windows XP box, and it will register the packets going in and out of that connection, which will be the voice conversation from the soft phone running on the Windows XP box. Okay, so I selected the local area interface and I clicked on the third icon across, which is Start a Live Capture. And now what we shall do is we'll make a phone call. Answer the phone. Hello. 1 2 3 4. I'll just mute the sound for a moment on there so as we don't get any feedback. And you can hear me talking, and you can see what are called RTP packets flying up the screen. These are packets that are being captured from this phone conversation. RTP packets are real-time protocol. They contain the voice that's in the voice over IP conversation. I shall put the phone down now. Click. And I shall stop the capture. And very quickly we'll have a little look at what's going on in VirtualBox, in Wireshark. Wireshark has captured the packets, the RTP packets. In fact, I'm only interested in the RTP packets, so I'll type RTP in the filter box just to filter out RTP packets, and we'll rebuild the conversation. How do we do that? We go to Telephony, RTP, Stream Analysis. We've got both sides of the conversation. Save payload. We want to save both sides of the conversation as a .au file or an audio file. We'll give it a name. I'm going to call it Test 101 and put it on the desktop. Okay, believe it or not, that's done it. Just close the packet capture. And we've got Test 101. If I click on it, Windows won't know quite what it is because of the unusual extension, but Media Player can actually play it. So Windows Media Player doesn't know it can play it, but it is capable of doing so, and we'll play that conversation. I'll just turn the sound right back up again. Hello, 1 2 3 4. I'll just mute the sound for a moment on there so as we don't get any feedback. And you can hear me talking, and you can see what are called RTP packets flying up the screen. These are packets that are being captured from this phone conversation. RTP packets are real-time protocol. They contain the voice that's in the voice over IP conversation. I shall put the phone down now. And there you go. That was a voice call intercepted. So we did a little bit of Linux, we did a little bit of Cisco, we intercepted a voice call. It's a very basic setup, and there are so many security mechanisms you can put in place to stop this happening, but you would be surprised how many people don't really think about it and don't implement those security options. Things like, for instance, IP DHCP snooping, port security, and such like. Or even better, setting up secure real-time protocol. I'll do another little video similar to this using the open source Linux asterisk voice server. I hope you enjoyed it, and stay tuned.